This conference will now be recorded.
Am I audible? Audible?
Yes, Vishnu.
Yeah, thank you, Gaurav. So last session we stopped at the block, right? So today we'll be seeing that again because it was not that clear last time. So I'll be continuing from there. So let's understand what's a block and how generally a block is being stored in the DBs. So what is a block and all? Okay. So in this in now today you learn like what are these database blocks in detail. Okay. So now all the data in Oracle database is stored in blocks, right? Now in both disks, memory. Okay. So now like this Oracle database block, this it is very important to understand. Otherwise, what will happen is because why it is so important is because this Oracle it does not store like if you have a table, it does not store a whole table in one block, okay, and just return it directly from there, but it stores in a different algorithm. Okay, so now to understand that you need to understand what's a block. Okay, so how this Oracle stores a table, to understand that you need to understand what's a block, which is the smallest unit of the database for storing the data. So now let's understand regarding that, like what's a block and what is its significance and all. Okay, so now, like let's say I have a block. Okay, so let's say this is the block. So I have a block. So let's say this is my block. Just assuming, okay, this is the block. So there are various components to this block. That's what we are going to see now. Okay, so what are those components and what are its significance? Now block is the smallest unit of a database because there are multiple things like segment, extents, table space. There are multiple things like that. Okay, so block is the smallest one out of those. So now what is like there are millions and billions of blocks. Okay, in there can be, and which is used to store the actual data. So now this block has some minimum size. Okay, like for example, a block can have a size between 2 to 32 KB. So that is one standard. Okay, so a block can have a size between 2 to 32 KB. Now this is set by the DBAs inside the config file. So now there are like multiple ways to do that. We will come to that, like how generally it is set. But yeah, for now, generally the value is between 2 to 32. Now this default value is 8 KB. If you don't set anything, default value is generally 8 KB. Okay, the block size. Now inside this, now obviously the size is specified by the DBS whenever the database is installed, and uh, 8 KB is not 8 KB. Now if you feel okay, this is a block and it's just 8 KB, how much data can it store? It can store a lot of data. Okay, 8 KB is a huge size as per the data is concerned. There lot of data can be stored in 8 KB of size. Okay, so that's why 8 KB is not a small size. A lot of data can be stored, and that's what is a block made of. Now this block, now for example, you will have a lot of blocks, like thousands of blocks. Okay, so how will you identify what data is in that and what is that block for, right? For that only there are two components inside the block, which is the block header, we call it block header, and the rows. Okay, so now let's understand that. Now block header will have the informations like what is the block type, whether it's an index block or a row block. There are two types of blocks. Okay, so there are two types of block, two types of block. One is index block, this first one. Second is row block. So this detail, what type of block it is, it will be there in the block header. Okay. Now, so whenever Oracle is trying to fetch some data, it needs to know what block it is accessing, right? So that's why this block header will have this two data. One is what type of block it is, whether it's an index block. So index block is nothing but it's a block which is storing indexes. Okay, like there are a lot of indexes being stored in that block. That's why it's an index block. Row block is general data block. Okay, where it stores a different set of data. That's called a row block. Now, um, now whenever a row is stored, some amount of data is gone in say storing that row. Okay, like whatever data is in that row. Now this block be will be having that group of rows inside this. We can, like a group of rows will constitute this block. So let's say I have a row here. Okay, so this is row 1, then I have a row here, row 2, I have a row 3. So like this, multiple blocks will be there inside the block. Okay, so now if you see, okay, then there is r2, r3, then there is r4, r5. Okay, now this one I will keep it as ws, meaning I'm saying white space. Now see, generally whenever a row is stored inside a block, it will be stored like this. Okay, and there will be some white spaces in front of some rows. Some rows might be full. Okay, so what's the meaning of these white spaces? Like, why is it required, right? For example, if a row is 2 KB and the maximum size of the row which that block allows is, let's say, 4 KB. So after 2 KB, there will be a white space of 2 KB because total space is 4 KB, right? So this will be 2 KB and white space will be 2 KB. Now, why this extra 2 KB? Now, for let's say in future, my row size increases. Like I want to change the data type or I want to change the data what is stored in that row. Okay, so that time there has to be some space where it can extend, right? So that's why this white space is left. Now, so based on this, inside a block, when we see, there will be some amount of free space. When we speak the whole block together, like if you add this white space, all the white spaces, if you add together, there will be some free space. Okay, and there will be use space. Now this free space and use space is a very important bottleneck when it comes to performance tuning, because the blocks which have a lot of good free space are generally good, very good, like it's considered good, because if your free space is totally used inside a block, that means there is some problem, because you need to increase the block size, or you are not your algorithm is not working properly of dividing the blocks. Like whenever a new data is written, how the blocks are getting divided and how the blocks are being chosen to write that data is not proper. So that is one sort of bottleneck which we will have to fix. So how do we fix it, right? So how do we increase these spaces? Okay, so to do that, there are some parameters inside the db config. Okay, we call it pct free config. So I will explain that what it is. Now this, there are different parameters, or we can say attributes inside the Oracle config. Okay, in that Oracle config, there is something called PCT used and PCT free and PCT increase. Three are there, which are important. One is PCT. So basically, this you will find inside the Oracle config file. This parameter, like it will be something like this: PCT free equal to some 10 value will be there. Okay, it will be something like that. And also it will be PCT used equal to some 20, like that. Some values will be there like that. Okay, and PCT increase is equal to something. Okay, so like this, three parameters will be there. Now let's understand what are these parameters one by one. Now this PCT free, sorry. Now let's say if PCT free is equal to 10. So what does this mean is now Oracle will keep on adding new rows to a block until it is 90% full. That's what this means. So if I set PCT free is equal to 10, that means my Oracle, what it will do is it will try to write new data to this block only until it is 90% full. After that, it will create a new block. Okay, it will not continue to write in this block. That's the meaning of PCT free is equal to 10. Now, what is PCT used? PCT used also is similar to that. It is nothing but, now let's say if I keep PCT used is equal to 40, or not, let's say I keep it is equal to 30. Okay, so PCT used is equal to 30 means now this Oracle, it will not add any new rows to this block, to the block, whatever block we are, or generally it's not like a single block, it's for the whole database, right? So whenever, like what it will do is it will not add any new rows to the block unless sufficient row, like enough amount of rows are deleted from the block, so that it falls below 40% used. So like 30% used. So basically what we are saying to Oracle is keep the block size used to only 30%. 70% you keep it free. That's what we are commanding Oracle by saying PCT used is equal to 30. So whenever the usage goes above 30%, it will delete the unwanted rows or the old ones from those blocks and keep 70% free. So 30 is a very low value. Generally, it is above 50 or around 70 and all. Okay, so the 30 is just a small, very like it's a bit low value. Now there is something called PCT increase. Okay, so this PCT increase is also little important parameter. So this PCT increase, generally the value is from 0 to 100. So what does this PCT increase value means? Okay, so generally, for example, if you set PCT increase to 1, like let's say I keep the value to 1. So this, when you set PCT increase to 1, so whenever like for example, you like what generally does is it will, it's a size by which your next extent will grow. So extent is nothing but a group of blocks, right? A group of blocks will create an extent, and a group of extent will be segments, and that way. So whenever a new extent is created, so the next extent will grow by that much percentage. So for example, my initial extent was 2%. So my next extent will grow by 1% of like 1% extra of 2%. So not, sorry, it's not like that. So let's say 2 KB is the size of my extend now. Okay, now what it will do is it will add 1% to it. It is 2.02 KB. Let's say it will be the next extend size. So similarly, it will keep on adding the memory size as per the extend size of the previous one. So that's what this PCT increase generally means. Generally, it's kept to 0 or very low value. Okay, not very high value. It's generally kept to 0, some lower value, so that you don't run out of memory by constantly increasing the memory. Then there is at last one more thing you need to understand regarding block, which is something called ASSM. So let's see what is that. It's called ASSM. So ASSM is nothing but it's called automatic segment space management. So it is a method used by Oracle to manage the space inside these data blocks. Okay. So what it will do is it eliminates the need to like you don't need to specify PCT use free and all those. Like automatically, what Oracle will do is it will automatically manage the space. It's more sort of like a automatic segment management. Okay. So now to do that, generally some logics are used. We don't need to go that deep into that, but you just need to know there is something called ASSM also. Generally, when DBA switch on this, the other things will be overridden, like PCT used will not be considered by Oracle, or this ASSM will be valid. Okay, so that time automatically Oracle will maintain that memory and also that it doesn't create any bottleneck. Okay, so that's it. But yeah, you need to know there is something like this also, because if this is leading to some bottleneck, we need to analyze. Right. So now inside this block, now what I do now, I will just zoom into this R1. Okay, this R1 is one row inside the block, right? So I will just zoom into that R1. So I draw a row. So basically a row block. Okay, and this row block has majorly two sections. Okay, now the one section which we have is the row header and the column header. So let me open that. See, now you have a row header and the column data. Okay, row header and the column data. Now this row header will have multiple other like parameters. Like for example, it will have the row overhead, the number of columns, the cluster ID, the row ID, and all those stuff will be there inside this. Okay. So now what are the significance of those? It like let's say I have a row header. Now, for example, if what happens is sometimes sorry, so my dog. Yeah, sorry, my dog. Yeah. So there is a row header. We have in row header there are some different parts. Something called row overhead, number of columns. So, but you don't need to go that deep into it because it's not that. But what you need to know is there is a row header and a column data. Okay. So yeah, that's regarding the block. I don't want to go deeper into this, and it will be a little boring for you. So we'll move on. Now let's see what is this program global area in little detail. Okay. Now generally in program global area there are different what we can say different parts to this program global area generally. So for example, there is a session area, there is a persistent area, there is a runtime area, there is a cursors area, and in SQL work area there is sort area, hash join area. Each has its own significance. So let's understand what that. Okay, like let's understand this PGA in little detail. Okay, Now this PGA is a program global area, we call it, okay, or private global area. There are different names. You can use any of those. Program global area, private global area, all are common names. Now this is a memory area um, that contains some sub areas also. Okay, so unlike the SGAs, PGAs are, right? It's private for each user. Like if you have one user, there is a different PGAs will be created per user. Now, so let's say now, if you have one user, do you think can other user touch that PGA? For example, now Girish has one PGA and Gaurav, you have one another PGA. What do you think? Like, can Girish touch your PGA?
No.
Yeah, correct. So you that PGA will not be accessible by anyone because it will be accessible to only that user whose it is. Okay. So every user will have their own PGAs allocated. Sorry. So as you see in the diagram, there are different, there's a session area, there's a private SQL area, there's a cursors area and a SQL work area. Now these are some of them like which are divided into more sub areas like which individually like this private SQL area has persistent area, runtime area. Then there's a cursors area. Then the SQL work area has this sort area, hash join area and bitmap merge area and bitmap create area. So first one is a session memory area. Now, when a user connect to the database, okay, the database creates a session for that user. Okay, so that session is stored inside the session area, right? So it is now this is very important thing because though you don't need to go like what or but basically like you don't need to go very deep like what is the session area about. It stores the session information, but basically this area stores the sessions variables like login information, session status, etc. Okay, so let's say if you open some unnecessary connections, okay, now you should know what will happen. Now what if I open some unnecessary connections, like let's say there are what the sessions what I want to process the queries is 5, but instead of 5 I open 10 session areas. What is the drawback behind that? What do you think? Girish or Gaurav, any guess?
Yeah, it will occupy more area, more
Correct.
session
So
area.
basically, how much more unnecessary connections you open, that much unnecessary area will be consumed, right? So that's why whenever you're opening connections, you need to be really careful, like how much you're opening. You don't need to open unnecessary connections. So this is very important. Like for example, when you use some other languages, another language like Java or .NET, no, when you use these languages, sometimes what development team will do is they will forget to close the connections. Okay, and this causes some problems like memory leaks. No, this is one of the problem which we observe in databases, like keeping the connections open without closing those after it is after it's done with the task. Okay, so that's one bottleneck generally we observe whenever we are trying to analyze the PGAs. Okay, and it's very important also because more the number of users, more the load, more the PGA size. Okay, so more the sessions active, more PGA will be allocated and more memory will be gone in that. So you need to be really careful. Yeah. So next memory area, which is the SQL area. Okay, the private SQL area. So in that, it is divided into two sub areas: persistent area and the runtime area. So this persistent area generally it contains the bind variable values of the cursor. So what is bind variables and all we will see later. But for now, persistent area generally stores the bind variables. Okay. Now each query generally whenever it is run is turned to a cursor in the database. So we will generally what is a cursor, we will see if possible like cursor is little deeper topic generally, but whenever a query is like whenever in any query the database gets, it's turned into a cursor, okay, by the database. Now you can create an explicit cursor or an implicit cursor. Two types of cursors are there, okay. Now whatever bind variables you will be using in those cursors will be stored in the private SQL area, okay. And when the cursor is closed, this so generally the cursor related details will be stored inside the private SQL area, which is a persistent area. No need to go that deep, just I want just we will see what is it, because anyways we can't tune that much deeper because it's a DBA level topic. But we need to know, like whenever we speak to a DBA, we need to know what are these areas and what are its significance and all, okay. Right. So next is the SQL work area, different types of sort operation, join operations and all. No? Those related data is stored in the SQL work area. Again, this is also important area because it stores those sort of details inside that, but not of that much significance when we do some tuning, because we can't go that much deeper into the tuning generally. Okay. Now let's see the shared pool again. So shared pool, as we know, in there is data dictionary cache, result cache, and library cache, right? In data dictionary cache, generally what it stores table schema sort of things, like how many rows, columns, details of the table, indexes, and all those stuff. It's stored inside the data dictionary cache. Okay. Then there is a result cache. Result cache generally stores the result of the queries, result of the functions. So it is basically more sort of whenever you run a query, so if there is some result which is returned, that will be stored inside the result cache. Then there is something called a library cache. Now this library cache is very important with respect to the performance engineering if it's concerned, okay, because library cache stores one of the most important thing. Can anyone, any guess, Girish or Gaurav?
Explain plan, execution plan, and all. Right?
Correct. Yes. So generally, this library cache will be storing the execution plan, the explain plan, and that's very costly operation for DB, because that's where the real cost happens. Okay, like creating an execution plan and executing that. So better your execution plan, better your query execution will be. It's more sort of the foundation to your DB query execution. Okay, and that's stored inside the library cache. So more your library cache, more execution plans can be stored inside the library cache, and more better your performance generally will be inside your DB. So this library cache is very important when it comes to the execution plans and the performance of your queries is concerned. Okay. So generally now, let's say I have a query, I'm running it. Okay. Now, first time when it is run, the result will be stored, the table schema will be stored, the execution plan of that query will be stored in the library cache. And the second time, when that query is running, that stored data will be used to return the output of that query. Okay. So first time when I'm running, what do you think, whether the first time the response will time of the, like what we can say, the query execution time will be high, or the second time?
In the first time, it will take more time.
Correct, yes. First time it will take more time, and that's why it is called a hard parse. So whenever we speak like hard parse or soft parse, hard parse is when the data is not picked from the cache. Okay, and soft parse is when the data is picked from the cache. So whenever the data is not picked from the cache, maybe due to the data not available in the cache, or it's a new query, or due to multiple other reasons maybe. But more the hard cache, hard parse, more extensive or intensive the process will be. I mean, it will be a costly affair. So always as a performance engineer, our main focus is to reduce the hard parse. So if you have some queries, so how many hard parses are happening? Okay, so that is very important, and that generally we get the detail from the AWR report and all. We will see how it happens. But I wanted to call out this terminology called hard parse and soft parse. So hard parse is when the data is not picked from these cache. Soft parse is when the data is picked from these cache. Okay.
But Vishnu, I have a question here. See, if you are going to, when a real user is going to hit the application, okay, that
Yeah.
time what happened? That time it is taking more time, right?
Correct. Yeah.
Because,
So see,
because that
it's a
that
good question.
requirement is not getting stored in the cache,
Correct.
and they are getting the more time. Similarly,
Yeah.
some other user is going to use for a, I'm just sharing that information from the end user perspective. Okay,
Okay.
in the end, suppose you are a user and myself is also a user. You are just sitting to the server, and you are also getting the more response time. Similarly, it is happening for me also, right?
So that's a good question. See, now let's say I open Amazon.com. Okay. So I am another user. You are another user. Okay. So you are opening. I am opening. Does this first page change with respect to the user? Okay. If it changes, that's a different case. Now, does this first
Yeah.
page change?
No,
No. So the query is same,
I
right?
think. Yeah.
Getting my point, Arun? So the query is
Yeah, I
changed.
got it.
So
Mm-hmm.
yeah. So that query is already stored in the cache.
Mm-hmm.
Okay, but there are some things which are like changing always, as you said. It's correct. Like for example, login. Okay, login because I am sending the username, password, details, and all to the DB. So that might not be same for every user, right? So that could be
Yes.
different. But there are most of the things, generally 90% of the things which are common. The query. So now, for example,
Mm-hmm.
when I click furniture, the query which runs. When you click furniture, the query which runs is same, right?
Yeah, yeah, that's true.
So
But
that's
for
what is stored.
login, it is taking, it is not going to be same, right?
Correct. It will be little different, but we can't say always different because in that also sometimes how the query is written in that way it could be like you can sometimes optimize. But yeah, generally it cannot be. Okay, that I can say. Login and logout you can't. Log out you can, but login you can't. Okay.
Yeah.
So because it's more sort of you're accessing the PGA, you're creating a session in that, so it's a little different. Okay, but the other things like the catalog, but if you see, Arun, do you think catalog will be more intensive or login as per the
Uh,
queries?
maybe I'm going for catalog part
Correct. So
because
catalog.
that is our requirement. Login is
Correct.
not our requirement.
Correct. So catalog is more intensive operation compared to login because when I click on a catalog furniture, there could be hundreds of products which it needs to pick from the table and print, right? Or return the data. So it's a intensive operation. So those intensive queries, if you can store in cache, login is a simple query, right? Because I meant compared to this catalog and all. Getting my point, Arun?
Yeah, got it.
Yes. Okay, so that's how it happens generally. So that's how this helps to improve the
Means
performance.
you are just trying to say that if any end user is going to hit any type of request, in that case, before that request is also by using some other users hit, that is also present in the cases, so that other user also getting benefited on that. That you are trying to say, right?
Correct. Yes. And
Okay.
so even just once it should be run. And also, yeah, there is something called a cache automatic memory management, which is generally it will delete the older ones. Okay. So that also will affect your hard parts. Like for example, if your SGA size is very small, like you are keeping your SGA size to 500 MB. So as soon as it hits 450 or 480 MB, my older cache data will be deleted. Now, when that query will again come in future, obviously it will not find in the cache and again hard parts will happen. So that's why it's always
Yeah,
said.
see, whenever you are just going to hit by using a load test, it means that suppose how many capacity is to be there. According to that, it is providing some less time. But whenever it is going to clear, after that, which transaction is going to hit or that particular request, that time it will take more time. Again, it is
Correct.
going to normalize, right?
Yes, correct. So that's why see whenever this DB performance engineering happens, it doesn't happen like under load, like let's say 100 users or 500 users. It doesn't matter. Okay, what you do in performance engineering of DB is analyzing the execution plan. So it's independent of number of users. So only the connection, count of connections, and those bottlenecks you can focus on the number of users. But when it comes to DB performance engineering, 90% of the activities you will do without load also. You can tune it because a single load will be equivalent. You can multiply. I meant a single load, how much cost is there for 100 load, it will be multiplied by 100, almost like an extrapolation. Getting my point, Arun?
Yeah, Vishnu.
Yeah. Okay, so let's move on to the buffer cache. So again, buffer cache is another
Vishnu, I
important.
missed that point. Can you repeat it? What exactly you told? I missed something here itself.
Okay, so what I meant is in DB, when you go deeper into performance engineering of DB, you don't need the load as such, because only few of the parameters are those which you will be running under load. Without load also you can tune lot of things. That's what I meant.
Okay.
Yeah. So, okay, buffer cache. So let's understand what's a buffer cache. Let's see what's buffer cache in little detail. Okay. So like the others, we have mentioned, like I have mentioned, the buffer cache. So let's see little closer, because already we have seen what is a buffer cache, but let's try to understand a little bit more deeper. Like there are some other components inside buffer cache. Okay, as you can see, like there's a PGA, then from PGA it comes to buffer cache, and there's a database writer process, disk, and server process. So let's understand that, like how it generally happens and how it works. Now, this database buffer cache is the largest memory of the SGA. Okay, so under the SGA, the total SGA, if you see, buffer cache is the most largest memory we can say. Like for example, if SGA is 100%, around 70% of that will be buffer cache. Okay, because why 70% is the buffer cache? Because it is what is the which will store the data blocks. Okay, the cache of the data blocks, not like some execution plan or table schema. It will store the real data blocks, so it needs more size. Okay, so that's why buffer cache is a little heavy, bigger compared to other components. Now, as this area is in SGA, okay, this data is available for all the users. Okay, it's not like only Girish or only Arun or only Gaurav can use it. If all three of you are accessing it, all three of you can access that. It's not that it's accessible to only one or two or based on something, but it's accessible to all. And because it's in the SGA, because SGA, it's a shared global area, right? So it's accessible by everyone. Now, so let's say, so when the first user runs a query, like let's say a user runs a query, that data, whichever is read from the disk, is stored into the buffer cache. So whenever there is a first user, okay, and he accesses the data from the disk first time, okay, first time it accesses from the disk, what my Oracle DB will do is it will write the data to the buffer cache and then deliver the data to the PGA. Okay, so next time when that data is needed, okay, so like next time when that same data is being accessed or needed, it will be in the buffer cache. It will not go to the disk, because cache is faster than disk. If let's say cache takes 1 second of time, the 100 milliseconds of time, your disk will take, let's say, 1 second of time. At least 1/10 of your time will be saved by going with the cache. Okay, so that's why whenever a data is first read, it will be from the disk. Second time onwards, it will be always from the buffer cache. Now, now let's say I hit a query and there is no data related to that query inside my buffer cache. Okay, so now in those conditions, what will happen is, so always the flow is, you should remember, it is always buffer cache and like this. Okay, so generally what is happening is always it is going through the buffer cache only, the reading and writing both. Okay, from whenever something comes from PGA. Now, so let's say I read something and like I'm trying to run a query and I am seeing that data is not available in the buffer cache. So what my Oracle DB will do, it will go to the disk. Okay, so now this question might come to you. So why do we need the buffer cache, right? As I said, it's a faster, because it's faster to read from the cache than the disks. That's the most important thing. Okay. And the second is, now what type of data will be stored in the buffer cache? This question might come in your mind. So in buffer cache, only the data which is most recently used and also most used. These are the two data which will be stored in the buffer cache. Getting my point? So only the data, like for example, if I have a data X, if it is most recently used, like if I had a query which was run just before some time, and only that query data will be stored in the buffer cache, and also the queries for which I'm using again and again. Okay, like lot of times I'm using that query. Okay, also those data will be stored. So can you guess like what type of data will not be stored in the buffer cache?
User information.
Yeah, that is true. No, what I meant is like this one. If you read this statement here, what will be the opposite of that?
It is not,
Means
I mean, it is not frequently used, right? So
Correct.
either it's
So
a lot.
correct, correct. The data which is not frequently used, it will not store, and also the data which is not recently used, very old ones, it will delete. Okay. So these two things it will not store. Okay. It
Vishnu,
will store.
how it is going to recognize that that particular request is not going to hit, it will come the next time.
Yeah, so generally see buffer cache size is limited. Okay, like for example 700 MB or 800 MB. So as soon as it hits the max size, like let's say 600 or 650 MB, automatically the older ones will be deleted. Okay, and also the ones which are not, which are like the second priority will be the ones which are not used much.
There
Getting?
is some algorithms are there which is going to clear those data.
Yes, yes. There is something called automatic memory management by Oracle,
Okay.
which will take
Mhm.
care of. Yeah.
So we can't set any retention limit. So it's basically decided by Oracle, right?
You can actually, there is something called this buffer cache configuration. You can keep like how much buffer cache you have to fill, like for example 70% or 80%, that you can, okay, you can set. And also this total SGA size, PGA size, all is controllable. Okay, like for example if you set SGA size to 3 GB and buffer cache size to 2 GB, so those things and all are configurable. But yeah, see, obviously, after some time, if the buffer cache becomes full, it will automatically clear that. Oracle will not wait for anyone to say, okay, like Oracle doesn't like to fail its DB, okay. So that's why this automatic memory management is there. So if it sees the DB is failing or something, automatically it has a lot of features which it will trigger, okay, like to save the DB, because the data is what is very important, right? If your DB fails, the other data will also get corrupted. That it doesn't want.
Okay, so basically when we restart the database, this buffer cache will also, I mean, automatically it will, be flushed,
Yeah,
right?
yeah, yes. Yeah, yeah. Restarting will flush all the cache. Okay, like if you because restart is very last option for a DBA. Okay, so whenever you restart any server, the DB server, automatically all cache will be flushed.
So in that case, can a DBA do this? I mean, on like not just by Oracle, can DBA force buffer cache flush as well? Like if
Yes,
in
yes.
case it is
Yeah, they can.
required.
They can. Correct, correct. They can. You can flush even the library cache separately. Everything you can flush. Even
Okay,
PGAs, they can flush. Like if there are some connections which are creating bottlenecks, they want to flush the PGA to create fresh connections. They can do that.
okay. Now, when you said that in the cache we'll store all these explain plans and all, right? If we profile a query to
Hmm.
take a plan, right?
Yeah.
So that would also be in the cache then?
Yes, yes. Because see, now for example, you run the query, okay, and so whenever you run the query, that explain plan will be stored in the Oracle automatically, right? Because you are also running it. Getting my point? So now, but one thing is there are two things. One is explain plan and one is execution plan. So execution plan is after executing your query, Oracle stores the plan. Okay. Explain plan is before executing the query. We will come to that. No need to confuse what these are. But what I meant to say is execution plan it will store. Explain plan it will not store.
Okay.
Yeah. Right. Yeah. Okay. So yeah, let's move on. Yeah. So yeah, okay. So now there is something called database writer process also. So generally what happens is now any DML operation, if it happens and some data is being accessed by the buffer cache, like you're deleting or you're updating some data and all, and it's in the buffer cache. Okay. So now that data, if I update in the buffer cache, shouldn't I update it in the disk also? Getting my point? Right? So buffer cache, if I update, I should update that in the disk also, right? Whatever update I have done in the data DB, because we have to keep a similar copy, whatever is there at least, right?
Yes. So
So
any
that's why,
insert or update, yes.
yeah, so that's why this database writer process is used. So whenever some DML operation happens, this database writer process will write that data also to the disk and the buffer cache both. So buffer cache will also be updated. After the buffer cache is updated, database writer process will write that data to the disk also. That way we keep similar data in both the buffer cache and the disk. Okay, so let's move on to the next component, which is redo log buffer. Okay. So we know that like Oracle guarantees, okay, like there won't be any data loss generally. Okay, if they guarantee 99.9% time, there won't be any data loss. Okay. So how does it make sure, right? Like there is no data loss. So it makes sure that there is no data loss by using this component called redo log buffer. So one of the actions which it does is by creating some redo log files. Okay. So now let's understand what is this redo log files. Okay. So a redo log file is created whenever you, let's say, insert or update or delete or create or some operation like some DML operation, data manipulation. That's what I'm saying. DML means, okay, whenever you do some DML operations like that, where you insert or update, not read, okay, anything other than read, okay, where you're updating something, okay, those sort of details when you do, uh, a redo log entry will be created. So what my redo log buffer will do is whenever there is something updated in my DB, it will create a redo log file for that. Okay. Now, so what generally, like, why are we using this technique? Okay. Now this redo log entries will have what changes I made to the database. Okay. So what do you think? Why can, like, where can I use now that? Where can I use this redo logs? Any guess?
Audit purposes.
Sorry.
For audit purposes, like, I mean, in the sense, if we can track a transaction, like what happened over a period of time, like in the last 1 hour or two.
That is true. That is also a very good application. Like something which is very common one which we require, like for example recovery, right? Like for example, I did something. Now I want to recover the old data. How will I do, right? So for that, I can use this redo log files. So that's why recovery operations for like even rollback, you can't, sorry, rollback you can't do using redo log. It's done using undo data. Okay, that will come back later. So rollback you can't do with redo log. Only recovery operations or even there's something called a flashback feature. Okay, we'll see what it is. So generally redo log is for recovery. Okay, like what if you do some changes, you want to quickly undo the change, or we can quickly go back to the previous state. So to do that, this redo logs. But the main problem with this redo log buffer is it is very small. Okay, so very small means like if your buffer cache is like, let's say, 2 GB. Okay, this redo log buffer will be just 100 MB or 200 MB or not even 100 MB, like it could be sometimes 50 MB also. And that's why what happens is now this redo log buffer is like a circular buffer. It's like a circular buffer. So what happens is my data is being written in a circular way. So as soon as if my redo log buffer size is 50 MB, so it's writing. Once it reaches the same point, no, what it will do is it has no further space to add more data. So it will delete these ones and it will keep on adding. That's why it's called a circular buffer. Okay, it acts in a circular way. So that's a drawback of redo log buffer, that it cannot retain the data for very long. Okay, because the size of that will be very short. So more the changes you make to your DB, more data will be written to the redo log, and lesser time frame data will be available for you. Okay, for recovery and all. So that is a drawback. But that's why for rollback and all, this cannot be used. For rollback, we use something called undo data. Okay, so let's see what is this undo data now. So any doubt in this redo log? Right, no issues. So let's move on to the let's understand what is this undo term basically. Okay, so we now this undo word I will be using again and again throughout my lecture. Okay, so what will happen is, so let's understand that before we, so whenever now next time I say undo, it will be this. Okay, so we need to know what is this undo table space and what is this undo. So when a transaction modifies any data, okay, what my database server will do is it will copy the original data from the disk and store them into the memory before modifying it. So let's say, so let's understand what is this undo data. Okay, so let's say I have a DB. Okay, so I have a table like let's say employee table. Now I want to make changes to this employee table. Like let's say I have a lot of rows, okay, and some columns also. So this is some salary, this is some date of joining, this is last name, okay, and there are rows 1 2 3 4. Oh sorry, okay, yeah, 1 2 3 4 5, like that. Now some x y, some values we have inside that columns. Okay, so now let's say I'm changing this y, this date of joining. Okay, so when I am changing this, so let's say my query is coming, okay, and I want to change the query. Before I change it, what my Oracle DB will do is it will create a copy of this employee table and store it in undo table space. So one copy of same table will be there in the undo table space. So now why this will be useful? Now I made a change. Now I want to undo this operation. Like I don't want to make any change. I want to bring back my DB fully. Okay, back to the back to how it was. I can do that using the undo table space. So, but the only now this question might come: what's the difference between redo log buffer and undo table space? Now this redo log buffer is very small. Okay, but undo table space is very big, because the table size can be very high, like 100 KB or to maybe even MBs. Okay, like some 50 MB size. Okay, but this redo log size itself is 5 MB max, which it can store. It cannot store big tables and all. It will store only the detail of what is changed. It will not store the whole table. Okay, so that is why that's the main difference between undo and redo log. Okay, and this undo, that's why it is used for rollback, not the redo. Okay, because you can roll back total DB, total table itself using the undo table space. So that's why the original data stored into the memory is called as undo data. Okay, and another copy of the data is stored in the buffer cache for the modifications. So there are two copies which are made. One is in the undo table space and the other one is in the buffer cache. Okay, now this undo data is not modified because It is used for rollback operation, as I said. Then it also provides read consistency. Can anyone guess what it is? How undo table space provides read consistency? Is it clear, like what is undo table space and like how what's its use, or any doubt in that? Like Arun, Girish.
Can you say simply refer for future reference?
Correct. Yeah, it's a replica, right? It's a copy. Correct. That way you can simply say it. Okay. And but it is not stored in the cache. Okay. It is stored in the
Right.
disk. Yeah. So now my question is this point. Okay. Can any guess, like, used for providing read consistency?
Vishnu, so undo table space is something which is created in the disk, right?
Correct. Yes. Yeah.
Okay.
So see, now what we mean by disk consistency, the read consistency mean, like let's say Girish and Gaurav both, or Arun, both three of you are accessing the DB. Okay. Now you, like let's say Girish is making some changes in the DB, like for example, writing something, okay, some updating some table or something. But Arun and Gaurav, or what they are doing, they're just reading it. Okay. Like they're just reading some data. Okay. So that time what will happen? The reading will happen from the undo table space and writing will happen in the real table. Getting my point? So once this operation of Girish is complete, automatically the reading also will happen from there. Getting my point, everyone? So when that is happening, that writing is happening, no, in that small frame of time, the reading will happen from the undo table space until that change is complete and it's updated in the DB. So that the user, like other users, are not, like they don't feel any problem in what they're seeing. Okay, because anyway they are not updating it, so it doesn't matter to them. Like they're just reading it. Okay, so they can read the older versions also. As soon as this updated version comes, they will be reading from that once it's available. It's more sort of a locking mechanism. Like the person who is updating the DB will lock it, others will read the DB from the undo table space. So that's what is the read consistency we are maintaining. Now, used for providing flashback feature, again, there's something called a flashback feature in Oracle. Generally, what this flashback feature will do is, now, for example, you do some change. Some question, Gaurav?
No, I don't have any question.
Yeah. So flashback feature means, like, for example, uh, generally, like when you do some change in Oracle, uh, so what it will do is, now this flashback feature in Oracle, what if you ran a query, okay, in past, okay, and you want to get the data of those queries which you ran in the past, okay, so that you can do using the flashback feature. Because now that query has been updated, you don't have that query with you, okay, or that data with you, but you want to run a query, like which is a past query, and you some queries you need to run, which will return the past data which is before, okay, that you can do using the flashback feature. Generally it is more sort of historic data you want to access, you can do that, okay, using the flashback feature. So this all you will be enabled by using undo data. So that's important. That's why this undo data is so important. Again, so now I'm saying undo table space, undo table space, undo table space. So undo table space is multiple blocks create extents, multiple extents will create segments, multiple segments will create table spaces. Okay, so table spaces are generally it can be a lot of tables inside, because segments itself there can be multiple tables. Even table spaces can like multiple like there could be multiple tables inside the table space. Okay, so it's a group of segments generally. Yeah, so next is data modification language. I guess what we can do is, before I go to this, Yeah, okay. We can do one thing. We can stop here for today. Any question I can answer now, or we can continue tomorrow. Girish, Gaurav, Arun.
No questions.
Yeah, there will be a little bit of because this is more sort of a performance engineering. So whenever there is engineering and not it's not a testing, there is a lot of background detail which you require. Okay, because you want if you are to engineer a system, you need to know the system in and out. So a little bit of a theory, or we can say what that system is built of, right, that we need to know. So that's why these things are very important, because directly if we jump into tuning and if I say you do this, it will get tuned, it will not make sense, because you will not understand what is happening in the background. Okay, again it will be little blind, and when in interviews they will ask, surely they will ask like what is a buffer cache, and how some questions, very tricky questions related to the architecture, you need to answer, right? Then only they will believe you really did some performance engineering or not, or just not reading some AWR, or just not reading something, right? So that's why these things will help you. Okay, that's why I'm going through all this. Even you can ask the queries also, like we can clear and go ahead based on that. Not an issue.
So I had one
So
question.
yeah,
Uh,
Girish.
so suppose I took in the current version of the application, I perform a load test or any of the performance test, whatever
Yeah.
it is, and
Okay.
I have the metrics like response times and all those we capture, right? Now in the next
Okay.
version, I perform the same test, right?
Hmm.
Now
Yeah.
in between these two tests, now if I have to identify what changed on the database level, in case if there is something changed, like
Yeah.
assuming that there is a new version of database that was upgraded, and
Okay.
then I mean, I have only that details. Now, how do I verify these values? Like whatever you told, like,
Hmm.
if there is a change in PGA, SGA, buffer cache levels between the two two runs. How do I do it?
Yeah, so one thing is you need to have some files with you, okay, after every version of test. Like for example, if there is any update, you need to be kept in loop. Okay. For example, like from DB version 1 to version 2, I'm going whatever, like let's say it's V1 to V2. So during V1, you should collect the configuration files, or like for example, the AWR you should have, okay, one AWR with you for that version. It will have the database related details and all, okay, inside in the AWR. Then also there is something you can directly ask the raw file of the Oracle config. Okay, so where can I find the Oracle config file? You generally you won't be able to access that. It's under the access of the DBAs, because it's little complicated. Like generally they don't give access to that config file. Okay, the configuration files. Now but you can find it easily inside generally. So when you ask for those files, no, the files which you are mainly interested is in the one is the php.ini file. Since you are asking this, I'm just rawly saying it. Okay, we can go through that later on also. Then the next is the dms.config file. There's something called dms.config file. And the one which you said, no, the SGA details and all, some of the details you will find in the AWR also. Okay, like the size of the SGA, PGA, the how much is filled and how much is the those details you can find in the AWR also. So AWR is very must. That's what I'm saying. So AWR is very must. You should have for every versions.
So what you're saying is a minimum of AWR report would give at least a brief picture about like what has happened in between the versions, right?
Correct.
In
Yes.
between the two versions.
Yes. Yes.
So
That's
these
why. That's
values.
why should maintain the AWR. Like after every upgrades and all, the older AWR should be there with you so that you can compare.
Okay, and these values that we discussed today, they are also, I mean, few values are also part of AWR report. That's what you meant,
Yes,
right?
yes, correct. Even SGA, PGA, the those sizes you can see, yes, in the AWR. Not all, I won't say all, because the redo log and all this, those are little deeper. Okay, you won't find that you will find only in the config. But yeah, again there is one more thing. Now these things, if you ask the DBA, they can get the data for you. You don't need to get the whole config details. You can ask them what is the size of the library. Yeah.
Yeah. Okay.
Hmm.
So if we know the parameters, then we can definitely ask. So that's
Correct.
important.
Yes. So like you can make a table and keep. Okay. Like for example, library cache size, dictionary cache size, SGS size, PGA size, the disk size, the buffer cache size, the redo log buffer cache size. This table you can send it to them. You can ask them like as per their leisure time, like bandwidth and all, fill it and send it back. Or else you can send me some file which has all these details. I can fill it. You can send a mail like that. So they will provide you.
Okay, got it.
Yeah. Yeah. So yeah, so any query, Arun, any query or Gaurav?
No, Dev.
Yeah,
No, Vishnu, not as of right
okay,
now.
yeah. Okay, so then let's stop here for today. Let's continue tomorrow. Thank you all and have a good day.
Thank you.
Thanks, Vishnu.
Thanks all.